Hello everyone, my name is Visatvik. Today my tech talk topic for theory of computation is trends and challenges for software engineering in mobile domain. I am from CSE-D section and my roll number is 20951A05G3. Introduction. During the past decade, the rapid rise of mobile computing has upended software engineering research and practice. Applications are now readily integrated on device capabilities from GPS data and wireless communication to camera, myriad and other sensors. Applications are also immersive, integrating their end users with rapidly changing digital landscape and leveraging dynamically available resources to enable more expressive sensing or to reduce energy consumption. The impact of these is evident both software engineering and in industry settings. New sensing contexts combined with power of mobility and ubiquity have radically changed how mobile software is developed in industry settings. The classical phases of software engineering no longer apply directly, and novel approaches, frameworks, and the changing landscape demand a substantial shift perception with respect to these classical approaches. New methodologies, solutions, and framework, and also different way of working are mandatory and require a direct link between research, industry, and end users. Engineering and development in mobile software includes forming the mobile software engineering professional, impact of mobile computing on software engineering practices, support for always on mentality, logical versus physical mobility, moving past on Android, going beyond mobile apps, transitioning research into industry. The impact of mobile computing on software engineering practices. Apps are GUI-centered, efficient, responsive, and appealing for user interfaces are the key for the success of apps. Apps require ultra-fast development cycles because of end users rate and review apps massively and at tremendous size. New versions of Android and iOS are released at least every year, and new competitors continuously pop up in app stores. Apps are very complex software systems that interact with many physical entities both inside and outside the phone and integrate devices, potentially third-party services in the cloud. Apps must also work on very diverse devices in terms of version of the operating system, sensors, etc. Context awareness enables the development of innovative features for mobile applications but create challenges for mobile software engineering. Being able to take advantage of different sensors on mobile devices as well as use data for end users can lead to improved user experience. However, these are trade-offs with energy efficiency, security, and privacy that need to be considered as well. Another unique aspect of mobile software development is the need to be adaptive. These challenges make fully automated approaches to adaptivity difficult. Moving past Android, with 88% of all sold smartphones being Android phones, Android has huge percent of the market share today. This is also reflected in the amount of scientific contributions of our Android in our flagship conferences. For example, out of 105 studies published in the technical track of a 48th edition of ICSC 2018, 15 studies are about mobile apps and among them 14 are about Android. We can trace this trend towards Android or two technical aspects. Firstly, Android is open source, meaning that researchers can customize the Android OS, integrating the solutions and perform experiments on them. The source code of the whole platform is available and versioned since the beginning, allowing the researchers to study the internals and platform and how it is evolved over time. Secondly, Android is heavily based on Java, a language that is widely adopted and taught in universities. Moreover, many researchers are comfortable with Java, thus easing their understanding about the specific phenomena happening in the source code of Android apps. Finally, today a larger amount of techniques, tools, and data sets exist for statistically analyzing and testing Android apps, which can be leveraged by researchers for scaling up the execution of new studies, thus leaving behind other apps specs of mobile economy system which are less covered. Example in terms of analysis tools. Going beyond mobile apps, wearables and constellations of IoT devices are revolutionizing the way we live. Example, smart home appliances, industry 4.0, healthcare, and will be driving research in near future. New applications of some mobile computing will likely have an even bigger impact, such as those enabled by machine learning, computer vision, augmented or virtual reality, natural language processing, and speech recognition. Privacy, security, performance, and energy consumption for mobile apps are being actively investigated by researchers and practitioners, but they have not been fully explored in the context of these new applications of mobile computing. From the infrastructure perspective, we are moving towards a continuum where computing starts on mobile devices and continues onto edge and cloud infrastructures. Researching also reaching also many other devices, example ISP gateway, cellular based stations. We need solution to exploit such a continuum in flexible way with pre-deciding the allocation of components and thus language and tools to create them. Edge infrastructures may add new interesting dimension to the problem of managing computationally heavy tasks on mobile devices, especially in the context of wearable devices with very limited battery life and computational powers, connected cars and smart objects, example home automation and advanced logistics. In this context, a possible step forward may be the combination of microservices architectural style and develops concepts for dynamic surrogate provisioning at the edge, networking protocols that deal better with intermittent communication such as delay tolerant networking, a new business model to support cyber foraging at industrial scale. Cyber foraging will be one of the enablers of augmented reality, given that performing image recognition analysis are crucial elements of augmented reality framework like Google AR Core, but they are extremely expensive for mobile devices both in terms of performance and battery consumption. Transitioning research into industry, if we do get research papers on mobile software, we see spectrums of solutions ranging of from narrow studies on low-level aspects of mobile app development, example how Java collections may impact the performance of to system-level approaches on whole mobile ecosystem, example new permission systems for Android. Our perception is that narrow and in-depth studies may be more easily adopted by the industry, example a new static checker for Android Studio compared to wide studies which may strongly improve but also disrupt the current status quotient. Adaptability is also facilitated by the development of well-tested and maintained tools embodying the research results proposed by researchers so that the industry can independently verify, check, and start using the proposed solutions. However, if on one side we know the industry experts to ready to use solutions, on the other side going too much towards this model may lead to risk of not focusing on more fundamental problems which may be more rewarding in the long term. As often happens in software engineering, it is up to involved players to find a right trade-off. The first step is to build certain sensibility with respect to technology transfer process, user starting point, and to learn from known success stories. From our experience, we learned that when setting up a collaboration, the first and necessary condition towards success is to share the discuss upfront the goals of both academic and industrial partners and let them to converge. This shields research from running the risks and not considering realities of operational environments and also falling into the trap trying to sell to industries the answers we have without listening to their questions. For me, mobile software engineering professional, when talking about the future of software, it is inevitable to acknowledge supreme value of students, both computer science and other disciplines. And on their professional education, this leads to following key question. What is the role of education in forming the next mobile software engineering professional? Mobile software engineering is a very applied topic, which is very applied program would be preferable. Or hypothetical program would be composed of four main orthogonal dimensions: foundations, experience, business and research. Foundations is the large dimension and it includes software engineering and system engineering courses at different levels, followed by mobile specific software engineering courses. Given that a mobile software engineer these days is in charge of realizing software how much which will be likely part of users everyday life, the experience dimension entails course related to human computer interaction, user experience design, GUI design, etc. The business dimension aims at providing instruments for setting up and working with the software company. Example, a startup, we have courses about entrepreneurship and business related topics. As far as the research dimension, students would find a real problem to work on, study the current literature on solutions for that problem, and then propose a solution that is novel and advanced the state of art. Orthogonally to these four dimensions, instructor will be in charge of building a rich interface between students and companies so to facilitate the transition towards the positions in the industry and their exposure to the industry relevant problems. Thank you.